Solve the assignment last one problem, ma'am.
Okay. We'll be doing that now. We'll be doing it today, maybe. You have, what is that last question? I don't remember. I'll check with that. Okay. Hope with this problem today, what we are solving, you may be able to solve that. Okay, Kishan. I think it's a roller problem. Roller problem with two rolls, correct? Okay, students, you are ready with your book, pen, calculator? Yes, the accessories are ready with you? Yes or no? Yes or no? Are you all ready with the materials? Okay. Understanding that you are all ready, we'll proceed with the next problem. Take this problem. A horizontal shaft with inner clearance of 1000 mm. A shaft, horizontal shaft with inner clearance of, repeat. The screen is visible, students. A horizontal shaft with the inner clearance with inner clearance of 1000 mm carries two spears of radius of radius 350 mm and 250 mm as shown in the figure. The weights are 600 mm and 600 Newton and 500 Newton respectively. What's the date today, students? What's the date? Put the date as, what is the date? What's the date?
18 June, ma'am.
Yes, 18 June. Put the date, 18 June. Continue the problem. Find the reactions at all points of contact. A horizontal shaft with inner clearance of 1000 mm, carries two spears of radius 350 and 250 mm as shown in figure. The weight are 600 Newton and 500 Newton. Find the reactions at all the point of contacts. Written, students? The problem is written? Yes or no? Yes or no, students? No? Written? The problem is written, students, with you? Those who are writing, they'll say yes. If not, you will not say anything. That is what I understood. Only 1, 2, 3 are writing. When it is a possibility of offline classes, no, I'll check your notes seriously. The class notes only. The solved problems only. Now, going to the problem. This is the problem which is given. Please write on this diagram. Write on this diagram, students. There are two spears, right? The clearance is given as 1000 mm. The clearance is given as 1000 mm. Okay. The sphere 1 and sphere 2. Draw the diagram neatly. Where you can see the point of contacts. Point of contacts are at A, at B, at C, at D. There are two spheres, 1 and 2. They are at point of contacts at A, B, C, and D. What's the sphere diameter of 1? What is the sphere diameter of 1, students? Students, what's the sphere diameter of 1? How much? 350 mm. 350 mm is radius or diameter? Radius. Yes or no? 350, I'll reduce. Carries two spheres, 350 mm and 250 mm as shown in the figure, respectively. So 350 mm, the diameter, radius is given. Radius is given 350 mm and 250 mm. This is only for my understanding what I am writing now. Don't worry. First you listen to me, students. First you listen to me. First you listen to me, then I'll ask you to write. There are two spheres, correct? Which one is having a radius of 350? Which one is having a radius of 250? Tell me now. Which sphere is having a radius of 350? Which sphere is having a radius of 250?
Ma'am, P is having a radius of 350.
Yes, sphere 1. This is sphere 1 is having a radius because it is huge in size. And this is a sphere 2 which is having a diameter radius of 250. Correct? This is a radius. Only the radius is given. Radius. Correct? This is only the radius. Now, can you tell me the diameter of this sphere? Sphere 1?
Twice 350.
Yes. So it is 700.
700, ma'am.
What is the diameter of this? 500 of sphere 2. Correct? Yes or no?
Yes, ma'am.
Yes, I can once again show that. So this is 350 plus 350, it is equal to 700. The diameter. This radius is 250. Is that clear now, students? Is that clear now? Okay. We'll go little quick. You have written the diagram. Diagram is written. Yes or no?
Yes, ma'am.
Yes, written. Now we'll move on with the next. What is the next thing? What I should do now? How many free body diagrams I'll get? Free body diagrams. How many?
2, ma'am.
2 numbers. For each sphere, 1. For each sphere, it will be 1. 1 free body diagram. 1 free body diagram. Okay. Now I don't know how many knowns are there, how many unknowns are there, I don't know. So I'll start drawing the free body diagram for both together. So let me start drawing the free body diagram for the sphere 1. Okay, sphere 1. free body diagram of sphere 1. This side I'll draw the sphere 2. Okay, I'll draw a line, dividing line. Now, sphere 1 is down, students, and sphere 2 is this top. Correct? Yes or no? I'll erase all this so that now tell me, students, the free body diagram for sphere 1. Free body diagram of sphere 1. Tell me now, everybody. I'll draw x and y axis. I'll draw the x and y axis. Now tell me. Quickly. No much time we have. Now what should I draw?
The first quadrant, ma'am.
Which one? What I should draw? This is first, na? This is second. This is third. And this is fourth. Now you should tell me now. In first quadrant, what I should draw? Where are the point of contacts for first sphere?
B, C, and D, ma'am.
Yes, B, C, and D. Now tell me, at B, C, and D, what are the reactions? And which quadrant it will lie? Now tell me at C. At C, how should I draw the reaction?
Perpendicular, ma'am.
Yes, perpendicular to the plane. So this is RC. How should I write here? Where should I write here?
Third
Along
quadrant, ma'am.
No, why third quadrant? It is horizontal. It is horizontal, student. Horizontal. Is that inclined or horizontal?
Yes, ma'am.
Horizontal.
Horizontal.
It will pass through x-axis. So this is, I'll clear this. So you find, what is this? RC, reaction RC you find. RC. Now what next? What next? Quickly you should tell me, don't take much time. Everybody in the class.
Reaction at D, ma'am.
Reaction at D. How it will act? RD. This way? Perpendicular to the plane. Perpendicular to the plane. So how I should transfer here? How I should transfer here to the free body diagram?
Vertical, ma'am. Upward.
Yes. Vertical upwards along the y-axis. It's not been resolved. It is vertical. RD. Now next. Where else you find? What else you find? You forgot very important thing. What is the weight of the sphere 1? What's the weight
600
of the sphere
Newton.
1? 600 Newton. How the 600 Newton will act?
Downwards.
Along which line I should mention? Which line I should mention here in the free body diagram? Along y-axis. Along y-axis. Find this to be 600 Newton. Then anything else?
B, ma'am.
RB, ma'am.
RB. How I should mention, for example, I'll take this. Yesterday only I told, if you don't get to understand what should be the direction of, yes. So you can assume just away from the point, okay? So it is coming in which quadrant, student, if I'm drawing RB?
First quadrant, ma'am.
First quadrant.
First quadrant, okay. Now give me the angle of RB. Angle. What is this angle?
48.18.
Yes, how do you calculate?
We have to calculate the PR and QR length, ma'am.
Yes, very good.
PR and PQ.
Now,
Cos theta is equal to PR by theta.
yes, very good, very good. You complete a triangle. You join the points P and Q. See, P and Q are what, students? They are the center of the sphere. Correct? Yes or no? P and Q are the center of the sphere. Okay. Now, if I extend this PQ line to the sphere, touching the sphere, right? So this becomes how much? This is 350, correct? Even this length will be equal to 350. What about this portion? I'll clear this part. Correct. Total diameter, just before you said it is 700. So this is this
250 and
radius.
250.
Yes, 250 and 250. So what is the length of PQ I get? PQ length?
600, ma'am.
PQ is equal to 350 plus 250. By geometry, students, it's all by geometry. 600 mm. Now, can I calculate PR? Yes, I can calculate PR. How I can calculate PR? I know the total distance as 1000. The container distance. What is this distance, students? This is how much? The radius. Correct? This is how much? How much?
250, ma'am.
So what is this leftover distance? Which is equal to PR. What is PR therefore? PR, you should write all these steps. PR is equal to 1000 minus 350 plus 250. How much you get PR? Please calculate.
400, ma'am.
What's the value you get, students?
400, ma'am.
400. Did you understand? How do you calculate? Did you follow?
Yes, ma'am.
Yes.
Yes, ma'am.
Now you give the value of theta. How do you calculate the value of theta? Theta. What you'll take?
Tan inverse.
Cos theta is equal to adjacent by. Hello, ma'am. Yes, please tell me, ma'am. And sorry, students, there was an immediate, very emergency call. Okay, now tell me, you understood? Did you understand? So cos theta is equal to adjacent by hypotenuse. Because I want this angle, students, I want this angle inclined with the horizontal. This is theta. If I say it is theta, so what do you get theta value as? Substituting
48.7, ma'am.
You are writing, everybody are writing this. Adjacent is nothing but 400. 400 divided by 600. Cos theta is equal to cos inverse of 400 by 600. I am writing for you only, students. Theta is equal to what is the value you are getting?
7, ma'am.
7 degree. Did you follow? How did I calculate this value
Yes,
of
ma'am.
PR and QR? It's a very common problem, students. They ask very repeatedly. You can do it very easily. Follow these steps. Okay. Now we'll go back to the free body diagram. Now tell me, this angle is 48.7 degree. Okay. Now what next? What next, students? ಹೇಳಬೇಕು. Drop x and y axis for sphere 2. Now transfer the forces one by one. First, by default, we'll transfer the weight of the sphere. What is the weight of the sphere, students? Weight of the sphere
500.
500. It should be straight line. You should be drawing a straight line. Okay, students. Then consider
B force, ma'am.
B. How should I mark B? RB. Now I mark
RB.
in this RB in this direction. Yes. For this also, for sphere 2, I should drop opposite, equivalent opposite to maintain equilibrium. To maintain equilibrium. Okay. So which quadrant it will come, students? Which quadrant?
Third quadrant,
Second,
ma'am.
ma'am.
Second or third?
Third, ma'am.
Third. It will come in third quadrant. This is RB. What's the angle? It's the same, 48.7. See, they are just twins, like a twins they are. Equal and opposite there. See, here also RB. Here also RB. Both are opposite in direction. Correct? Yes. What next? Any other force coming into picture? Any other force?
RA.
RA, very good. You find RA perpendicular to this plane. Perpendicular to the plane. You find RA. Find RA. Where I should mark RA? Where I should mark RA?
X-axis, ma'am.
Yes, very good. X-axis. I'll use other color. This is RA. Yes. Now, over, any other force is coming into picture for sphere 2? Is that done with sphere 2 free body diagram? Now, which one will start? For which free body diagram will start our analysis? For which free body diagram will start analysis?
Second one, Lamis theorem.
Yes, start applying Lamis theorem. So Lamis theorem is applicable with two unknown conditions only. Only if I have two unknowns and third value is been known, I can apply Lamis theorem with only three forces. So apply Lamas theorem for the free body diagram of sphere 2. Sphere 2. Now give me the values one by one. Big ಹೇಳ್ಬೇಕು. ಹೇಳಿ. 500.
500 by sine 90 plus 41.3.
90 plus 41.3 equals next RA divided by sine
90 plus 48.7.
yes, then RB sine 90. Now solve for it. What is RA and RB? You get 500 sine 90 plus 41.3 equals RA divided by sine 48.7 plus 90. Therefore, RA is equal to 500 into, you simplify, what do you get? 138.7 divided by sine 131.3 degree. What's the answer you get? RA. What's the answer of RA you get? What's the answer of RA you get, students?
For 439.26 Newton.
26 newtons. What about others? What about others?
Yes, ma'am.
Is the
Yes,
same?
ma'am.
Yes.
Yes, ma'am.
Yes, ma'am.
Proceed with the next. Calculate. Give me the answer for RB.
Ma'am,
690.10,
666.6, ma'am.
Yes, 600 and
66.6.
666.6. I'll check the answer 1 second, students. Some variations are there. Doesn't matter. Because of decimal points, 138.7 we are taken. They are taken as 182. No problem. Okay. Now what is the next? What's the next, students? What should be done next? Did you write? Everybody write this? Did you write this? Written? Do you all get the same answer?
Yes, ma'am.
Yes. Now how to proceed now? Next. What is the procedure to proceed?
What's that?
First sphere, ma'am.
Yes. Now we have to consider the free body diagram of sphere. What's the spelling? Sphere 2. Now draw the free body diagram, or else if you have, you can start doing. Okay. Now what should be the method to follow for the sphere 2? Sphere 2 or sphere 1, student?
Sphere
Sphere
1, ma'am.
Sphere 1. What is the method I should follow for sphere 1 now? How many forces are acting at a point?
4, ma'am.
4. Then I should use equations of equilibrium. How many equations of equilibrium I am using, students? What are the equations of equilibrium we have? We have sigma fx is equal to 0. We have sigma fy is equal to 0. and taken sigma moment at x is equal to 0. But among 3, how many am I using? I'm using only sigma x is equal to 0 and sigma fy is equal to 0. That's all. By using these two equations only, I'm getting the answers. I need not proceed with the sigma mx. I need not, if I take this and this, I'm getting the answer. So I'm not proceeding with sigma mx. So only two conditions are enough to solve coplanar, concurrent or non-concurrent force system. Keep this in your mind, students. There was one question on this. Okay. Now to proceed, start drawing. If you are drawn, well and good. If not, you draw once again. Let me draw once again. Draw once again. Resolve the forces. Resolve the forces, students. Very neatly you should draw. Very neatly you should draw. This is RB. Tell me now, this is W1. Correct? What is the value? You are not helping me here.
600, ma'am.
600. 600. Yes, tell me now. Here you find RA. This is RA?
RC, ma'am.
RC. This is RC. Then what is this?
RD, ma'am.
RD. So you find only the resolution of only one force, RB force. Isn't it? RB force has to be resolved. What is the angle of inclination? 48 point. How much you have taken?
7.
7, ma'am.
0.7. So this is always, you know, you should take it to the second decimal. Okay, next problem onwards, you take it to the second decimal, students. Okay, always you take it to the second decimal. RB cos 48.7 and this will be RB sine 48.7. Now, which equation I'll be using now to start?
Sigma fx equal to 0.
Sigma fx is equal to 0. Now, what are the horizontal reactions you find? You find RC, then you find RB cos 48.7. Okay, very correct. So, we'll be using R. What is the sign rule? All positive moving, right moving positive, all left moving negative. So, plus RC, then
Plus R.
Cos 48.7.
RB cos 48.7 equals 0 and no other force, and we don't have any other force. What's the next I should use? Do I have any known value here? I don't have RB, I don't have RC. Do I have RB?
Yes, ma'am.
What is RB value?
$666.5, ma'am.
5 cos 48.7 is equal to 0. Therefore, RC is equal to minus 666.5 into cos 48.7. What is the value, students, of RC you're getting?
439.89.
430?
39.89.
39.89. What's the unit?
Newton, ma'am.
Now next I'll proceed. Sigma V, sigma Fy equals 0. Any doubt here, students? Please let me know. Tell me the equation now. Tell me the equation now.
RB sine 48.7.
Plus or minus, you should tell me always with plus or minus.
Plus RB, ma'am.
Plus, ma'am.
What I should write? RB?
Sine 48.7 plus RD equal to 0.
That's all. You don't find the load. Where's the load?
Plus 6.
Minus
600
Minus
Newton.
600 equals 0. So substitute the values and calculate RD. Check the answer. What's the answer you are getting? RB value, how RB value is 666.5. What's the value? RD? What's the value of RD?
Ma'am, minus 100.12.
Minus 100.12
Newton.
Newton. That's all. Correct? Any other answer? Anybody? So what were the unknowns? Did we calculate the unknowns? What was asked? Yes or no? It was asked to find the reactions at the contact surfaces. RA, did we calculate the value of RA? RB?
Yes, ma'am.
RC?
Yes, ma'am.
And RD.
Yes, ma'am.
Okay. It's all been calculated. Okay. Any doubt here?
Getting positive.
Yes?
Ma'am, RD getting positive value, ma'am.
You're getting positive value. Check the answers once again, students. Check the answers once again.
Positive, ma'am.
Positive. Don't go wrong like this. Okay. Is there any doubt you have here, students? 35 students are there in class. Huh? Clear with the problem? It's very easy. With the yesterday problem and today problem, you are able to solve the assignment questions. Am I sure? Am I sure?
Ma'am, fourth question. Ma'am, we're not getting the fourth question, ma'am.
Fourth question of the assignment?
Yes, ma'am.
Yes.
I'll check with the assignment. One second, students. 1 second. This is a question, right? This is a question paper. Find
Yes,
the
ma'am.
resultant of force system and find the points where the resultant will cut x and y axis. What's the doubt here? You're not understanding with the moment?
Yes, ma'am. Should we find the moment, ma'am?
Find the resultant, you have to find the resultant R, okay? Tomorrow I'll do this problem. Don't worry, I'll do this problem, solve for you, okay? Or yes,
Ma'am, we have to submit it tomorrow, ma'am.
tomorrow evening, right?
Yes, ma'am.
Yeah, morning I'll do this problem. Don't worry. You have to take.
And also,
Huh.
the first question, ma'am.
Also the first question. Okay. One thing we'll do tomorrow. We'll discuss these questions. Huh? Can we discuss this question?
Yes, ma'am.
Yes. In this, what is the doubt actually?
First question, ma'am. Explain the steps involved in finding the magnitude and direction of the concurrent. So, what notes? I mean, what we have to write, ma'am?
You have to write a generalized statements. I'll give you the materials tomorrow. I'll discuss the material tomorrow. We have to tell step by step resolution, resolve the inclined forces to horizontal component, vertical component, and sum up all the forces. Then calculate the resultant is equal to, we have the equation of R is equal to under root of sigma fx square plus fy square. Correct now? That method
Yes, ma'am.
what we follow. Yes, we have to express that. Okay, so I think better we'll discuss this assignment tomorrow once again. No problem. Okay.
Yes, ma'am.
Yes, I think one of the students also raised this point in initially of the starting of the class. Everybody has taken this? Taken the students? Okay, I'll stop the
Yes,
class.
ma'am.
Yeah, I'll stop the class and I'll take your attendance. Once your attendance is done, you can leave the class, students. Okay. Any doubt, you can ask me once again. Aditi?
Present, ma'am.
Aditya?
Present, ma'am.
Aditya Rao? Likit? Charan S?
Yes, ma'am.
Present, ma'am.
Geeta?
Present, ma'am.
Sri?
Present, ma'am.
Karuna? Kishan?
Present, ma'am.
Yes, ma'am.
Mohit?
Ma'am, Karuna present.
Yeah, I'm at. Pavan P?
Present.
Now?
Present, ma'am.
Akash?
Present, ma'am.
Rishika?
Present, ma'am.
Rishi?
Yes, ma'am.
Rishika?
Present, ma'am.
Rohit?
Present, ma'am.
Aida?
Present, ma'am.
Then Triparna?
Present, ma'am.
Vasant?
Present, ma'am.
Vimla?
Present, ma'am.
Present, ma'am.
Where were you, Abhishek, last two classes?
I'm out there, ma'am. I went to vaccination.
Bharat?
Present, ma'am.
Ethan? Dhruva?
Present, ma'am.
Harini?
Present, ma'am.
Yesterday absent, Harini?
Yes, ma'am.
Manish? Mohit Nayak? Mokshagna Teja?
Present, ma'am.
Nitish?
Yes, ma'am.
Pavan? Nand? Uttam? Vamshi? Vikas?
Present, ma'am. Present, ma'am.
Who?
Prashant. Prashant is present, ma'am.
Vinay? Ashish?
Present, ma'am.
Chandu? Jay?
Present, ma'am.
Where were you, Chandu, yesterday?
Ma'am, I had some work, ma'am.
Charan K? Lam?
Present, ma'am.
Gurumurthy?
Present, ma'am.
Manohar? Rajwal? Pramukh?
Present, ma'am.
Where were you, Pramukh, yesterday?
Ma'am, I was present, ma'am. At last, some network issues came, ma'am.
Sunila? Shafahat?
Present, ma'am.
Yesterday, where were you, Shafahat? Darshan? Okay, thank you all.